Hi, I'm going to be talking to you about running Python code within your database. When I say database, I'm particularly talking about PostgreSQL. We in the PostgreSQL community like to refer to it as the world's most advanced open source database. It's an open source relational database that has ACID compliant transactions, stored functions, replication, and many more cool things. In particular, it's the stored functions that we care about today. Stored functions are very similar to stored procedures, and the idea is that it's a block of code that runs within your database. Usually you invoke it as part of a select, or as a trigger on a database. A query like a select or an update is relational in nature, but a function is procedural. So why might you want to use stored functions? The first reason is performance. You might have a query that selects lots of rows from a database, and you might need to walk through them, iterating and summarizing or computing something. A traditional way of dealing with this is to take your query, run it on the database engine, ship all this data back to your client, probably over a network link, process it in your application, and come up with a result. There's a lot of network round-tripping overhead, converting from different formats to other formats, and then back into something your Python data types. Some of that is unnecessary if you could just do your work inside of the memory space of your database engine. Stored functions let you do this. Because they're running in the database engine, you save the network round trips, and you save a lot of format conversion. Another reason is code reuse. You might be running in an environment with different programming languages. You might have some Ruby code, some Python code, some Java code, all working with the same database tables. And more often than not, they all have to do some of the same functionality, to implement the same business logic to create some calculation. So one option, you can implement the same routine in all 3 or 4 languages you're using. That kind of sucks. Another option is you can try to have ways of your Java call your Python, or your Ruby call your Python, and that kind of works, but it's kind of annoying. So instead, you can just move the logic into the database. All of these different languages talk to Postgres pretty well, and if you implement your logic once in Postgres, you can then call it from a client in any other language. Another popular reason for using stored functions is security. You might have a table maybe storing salary data, and another table with the time people worked on a project. And you might want to allow people to compute the overall cost of a project, query the database for this, but you don't want to expose the individual salary line items of everyone working on your project. So one solution is to write a stored function that runs in the database and looks at the salary data, the work allocation data, and compute a final result. This stored function would have access to all your data, all the rows, do its computations, but the people who can call a function only have access to call a function. They don't have access to read all your raw data. They invoke your function, the function elevates its privileges to a higher privilege level, does what it needs to do, and returns a result or set of results to the callers. Another reason people use stored functions are triggers. Many database engines support triggers. A trigger is a block of code that's attached to a table and gets invoked on an insert or update or delete that does something. Maybe you have an order table, and every time someone files an order, you want to run some logic that creates work items for people to do things in a work item table. Your trigger has to be, because it's running in the database, it has to be implemented as a stored function. So how do we traditionally do stored functions? Most databases use something called PL/SQL, which is a form of SQL for doing stored functions. Each database engine has its own dialect. There's the Postgres dialect, the Sybase dialect, the SQL Server dialect. They're all generally pretty similar. You have variables, you have loops, while loops, for loops, can do queries, walk over these queries. But that's usually about all you get. It's not the greatest language syntactically, and it's not the most full-featured language with respect to modules and libraries. So Postgres has an alternative. In Postgres, we have pluggable languages called PLs for doing stored functions in a variety of different programming languages. You can write your stored functions in Ruby or Perl or Python, among many others. PL Python is the way you do stored functions in Python and Postgres, and that's what we'll be talking about more today. Why Python? Well, this is a Python conference. I'm not going to spend a lot of time preaching to the converted. In my opinion, Python is more readable than SQL. Where I work, we have a fair amount of large-ish PL SQL functions, and whenever you have to debug these things, it's kind of painful. They're a bit long. Calling, having one PL function call another SQL function is a bit awkward, so often these things grow in length, and they're kind of messes. The code, in my opinion, would be a lot more readable if they had just written it in Python. So how do we do this? How do we use Python in Postgres? First, you have to make sure PL Python is compiled with your Postgres. It's a compiler option on configure. If you're building Postgres from sources, you just go with Python and it'll compile. If you're installing Python from package management, RPMs, or debs, usually it's a PostgreSQL-PL Python RPM or deb. They're included within the distributions of Postgres for most major distributions. Make sure it's installed. Once the binaries are installed on your server, you can then install or enable PL Python in each of your databases. You do this in Postgres 9.1 or 9.2 with the create extension command. This is a SQL command you'll execute as super user, and you do create extension PL Python U, and that will enable PL Python in your database. If you're using an older version of Postgres, older than 9.1, the instructions are a bit different. There's a couple things I talk about here that are 9.1 or 9.2 specific, but most of the rest of the talk is doable in the older versions, but details might change. Once you've installed PL Python, you then get to write a function. The first line of your SQL function or your stored function is the same as the SQL function I had a couple slides ago. Create or replace function. You list the arguments the function takes and the result. Once you're done that, in the body, instead of putting PL SQL, you can put Python. And you can put pretty much any valid Python you want in the body of the function. In this case, we have a function that's going to generate a list of items from 1 to counter, where counter is an argument you pass in. Pretty simple stuff. Here we're doing it with a loop. This is the same function that I did in PL SQL a couple slides ago. We just loop through our list, add an element to the array each time, and return the array. Yes, you can do this in one line if you want, but a loop is a bit more interesting of an example. So how do we call this? You do select myfunc2, pass in an argument, and you get back the result. If I was returning a single integer instead of an array, I would get a single integer as a result. If I was returning an array of hashes or array of maps, I would get back a multi-column output, as if you were to select from a multi-column table. Once we get beyond that and we do more interesting things, you're going to want to use Python modules. Python is great as a stored function language because you get all these modules to do anything you can imagine are available. If you have a module installed on the database server, either through your package management or pip or whatever, you can call this module from your PL Python functions. You just call the module as you would in a normal program. You import the module, in this case the fractions module, and you use it. Here I'm creating a couple of fractions instances, adding them together, and returning the result. Simple stuff, and the more complicated stuff you'll want to do with modules is sort of by the same token. But while I said you can use any module available, that's not entirely true. Your PL Python code is running as part of the memory space and the process space of Postgres. Your modules are running as part of the memory space of Postgres. So you want to be a good citizen. When you go to get invited to a wedding and you bring a guest and your guest misbehaves, you're sort of responsible for your guest's misbehavior. And by the same token, you're responsible for the things the modules you call do. You should not be doing things like forking. If you try to fork the Postgres process from a stored function, or your module does this, you will be in for trouble. If you mess with the signal handlers that Postgres installs, it will probably not end well. And this is not a complete list of things you can do to screw up the Postgres process. So you should be aware that you're running in the memory space, and be aware of what's going on and think about how this might screw up Postgres. A more common thing you might want to do in a stored function is make calls back to the database. Call the database to get some data and do something with it. So how do we do this? We use the PLPY module. This is the interface PL/Python presents to your stored functions for calling back to the database. Your stored function is running as part of a database connection, as part of a database transaction. And the calls that you make back into the database will be part of the same database transaction. So you don't have to worry about a connection user ID and password here, because you're already part of a database connection. You execute you prepare your statement, and you execute the code, the SQL code, and you can process and iterate over the result. I will point out that the API for PLPY is not the standard Python DB API. It is different, but you read the API docs, get familiar with how it works. It's pretty straightforward, executes, looping over a result, etc. So, as I said, you're running as part of the same transaction as the database, as your stored function is invoked in. So, let's say you're, by default, if your database query, your SQL query, gets an error, it's going to throw an exception. That'll abort out of your PL/Python function. That'll abort the SQL call that called it, and this is going to roll back your database transaction. This might be what you want, but it might not be. You can also handle exceptions and do things on errors if you so choose. How do we do this? You first open up a try block, and within the try block, you do a subtransaction. You do with plpy.subtransaction, and everything within that block is going to run as part of a subtransaction. This subtransaction, if it aborts, the exception will get thrown up. You can catch this exception. Your subtransaction will be aborted, but the main transaction will stay intact. So in this case, I'm trying to insert data into a table with a unique constraint. If I get a unique violation, the exception handler catches it. It increments the number by 1 for the unique key and tries it again. And it keeps looping until it finds a number that works. I'm not saying this is how you should write your programs. Postgres has serial data types that give you auto-incrementing for you. But it's a nice example of how you can catch your database errors, do something different, and respond to them. So I mentioned a couple minutes ago that the API we have for calling into the database is not the standard DB API that you get with a lot of Python things like scicop PG2. This is kind of awkward if you're writing a lot of code, some of it which works in the database, some of it lives outside the database. So Peter Eisentraut has written a Python module that will wrap the PLPY module and make it behave like a standard DB compliant interface to the database. You can import this module from your PL/Python code, and you do a connect and a cursor, and then you have a database connection object and a database cursor object that behave as they would if this were scicop PG2 code or your standard DB compliant modules. So what you would probably want to do is create these objects and then work with these objects instead of the raw PLPY calls. When you start to write a lot of PL/Python code, you're going to want to think about code organization. My recommendation to you would be that you have your SQL files. This is the create-or-replace functions with the body that go in, and you're going to want to keep these small. I would recommend you try to keep these like to 3 or 4 lines. Basically do an import, maybe set up the, do the PLPY DB stuff to get a cursor and a database connection from the previous slide, and call into your module. And that's about all of the code you should be putting in the SQL. The SQL stuff you'll have to install into the database, just like a table. With PSQL, instead of doing a create table, you will do a create or replace function and install your code there. You would then have Python modules, normal PY files that have the meat of what you're doing. You would do this, again, you would either import PLPY or whatever module you need, and you'd have functions that you would actually get invoked through your stored functions that do interesting things. If you structure your code this way and you're careful, you can actually call your code with outside of the database as well. So you can write unit tests or debugging. You can call normal C Python, call your module, do a test, and invoke most of your code this way. This allows you to debug things with your Python debugger. Debugging from within the Postgres process is kind of difficult, but if all your code works both in Postgres and outside of Postgres, your debugging life will be much better. So that's all of the material I have, but I'm happy to take questions.
I was wondering, because you are importing modules
Yes.
in your scripts, and I would like to know where is Postgres looking for those modules? It has a virtual env for itself, or it's looking in the system? How does that thing work?
It'll look through at the standard Python library paths where Python will look when you compile your Python. If you do something like set a Python environment variable to search for libs elsewhere, before you start Postgres, that will have the effect. So any environment variables you set before you start Postgres are visible to the Python libraries.
Okay, cool. Thank you.
I just have a question about the last few slides that you were
Yep.
talking about, and I wasn't sure about the nuance. You'd write some of the select statements in Python, and you'd store that in the database, and then you'd call it out externally with another Python library?
So yeah, the idea is that the create or replace function goes into the database, and that's the code there. But it calls modules, and these modules can be the modules that you write yourself. So these modules would obviously have to be installed on the database server, as any other Python module would. But that's where you should put most of your code.
So the logic for looking up all the particular stuff I want to do in Python.
Yes.
And then I would call that from my code anywhere I want.
Yeah. So your database function would call that if that's what it wanted to do.
Okay, cool. Thank you.
Hi. So as sort of a SQL adverse person, I'm one of the PyTables developers, and we do a lot of out-of-core in kernel calculations using num expression, and this seems very similar, right? You can even persist these Python function objects and throw them back in your HDF5 file if you wanted. I was wondering how the performance of this would compare to something like that. You probably have.
I don't think I can answer that off the top of my head.
Okay, but is it a similar idea to the best of your knowledge, or?
I don't really. I've not used PyTables, so
Okay.
I don't know.
No, sure. Yeah. Okay, I was just wondering. Thanks.
Okay.
Okay, so we have to move on to the next speaker. Let's thank Steve.
Hi, I'm going to be talking to you about running Python code within your database. When I say database, I'm particularly talking about PostgreSQL. We in the PostgreSQL community like to refer to it as the world's most advanced open source database. It's an open source relational database that has ACID compliant transactions, stored functions, replication, and many more. Your client, probably over a network link, process it in your application, and come up with a result. There's a lot of network round-tripping overhead, converting from different formats to other formats, and then back into something your Python data types. Some of that is unnecessary if you could just do your work inside of the memory space of your database engine. Stored functions let you do this. Because they're running in the database engine, you save the network round trips, and you save a lot of format conversion. Another reason is code reuse. You might be running in an environment with different programming languages. You might have some Ruby code, some Python code, some Java code, all working with the same database tables, and more often. So why might you want to use stored functions? The first reason is performance. You might have a query that selects lots of rows from a database, and you might need to walk through them, iterating and summarizing or computing something. A traditional way of dealing with this is to take your query, run it on the database engine, ship all this data back to cool things. In particular, it's the stored functions that we care about today. Stored functions are very similar to stored procedures, and the idea is that it's a block of code that runs within your database. Usually you invoke it as part of a select, or as a trigger on a database. A query like a select or an update is relational in nature, but a function is procedural.